All right, so we should have already covered motor efficiency in the class, and so we're going to work through a couple of problems. Remembering motor efficiency, it's a fairly simple equation, but we just have to remember that one simple equation, and we should be able to work out everything else. And that equation that we're talking about is efficiency is equal to the output divided by the input. And remember, this is true for any type of efficiency problem that you're doing. It's not, strictly dependent on electric motors. This could be any kind of process. If you take your outputs, divide them by your inputs, you're going to understand how efficient that process is. And it just happens that in this case we're talking about an electric motor. So the first thing we want to do when approaching any motor efficiency problem is just write that down, right? We should have this stored in our head by now. It's just output divided by input, so just write that down. The next thing you want to do is to identify what variables that you have. So, do we have efficiency, do we have output, or do we have input? What are we given in our problem statement? So let's start off with that. So this problem says that a 2 horsepower, it's supposed to say motor there, a 2 horsepower motor requires 1,989.3 watts of electrical power to operate. What is the motor's efficiency? So automatically we know we don't have efficiency because that's what they're asking for. So let's just write down efficiency equals, I don't know. So the next thing, a 2 horsepower motor. If any time the problem is giving you the horsepower of the motor, that is the output. That is what the motor is capable of providing as kinetic energy or as kinetic power, like motion. So this motor can provide up to 200 or 2 horsepower of power. And so this is output, and so we're just going to write output equals 2 horsepower. And it requires 1,989.3 watts of electrical power to operate. That's what I have to put in, that's what I got to give the motor to get out 2 horsepower. So this 1,989.3 is going to be my input. After this, it is simply a plug and chug type problem. Now we're dealing with 2 different units here, and so we have an option. Do we want to deal with the units now? That's probably the best thing to do because we can't do any math when our units don't match. So we typically provide efficiency. Efficiency is unitless, so we have to have both of these in the same unit. We're given the conversion factor here, so 1 horsepower is equal to 746 watts. And so it's probably easier to just convert this 2 horsepower to watts. And so if 1 horsepower is equal to 746 watts, then 2 horsepower is going to be equal to twice that amount. So 2 horsepower times 746 is going to give me 1,492 watts. All right, and that is our output. So 1,492 watts. Again, we're looking for efficiency, so we just plug all of these values in here. We don't know what efficiency is. We have our output up top, so let's just plug in that 1492. Divided by our input, which is 1,989.3. And the cool thing here is we have watts on the top, watts on the bottom, and so these watts are going to cancel, and we end up with a unitless value, meaning it has no units. So doing this math, we have 1492 divided by 1,989.3 equals 0.750. So 0.75, or we can say that it is 75% efficient. Right? And there you go. It's that easy. In this particular problem, we were looking for efficiency, right? We did not know efficiency, but we were given output and input, and we could easily solve by just plugging in those values. We had to do a little conversion, right? But we're given a conversion factor, so we can do that conversion and get there. On the next video, we're going to be solving for one of these other either output or input, and we'll see how to do that.